We left off in suspense at the end of episode 0 about the relationship of so-called imaginary I to the surreal numbers. Conway's curious approach to this and his definitive book on numbers and games, the pure unadulterated take from the man himself, is that he deploys a kind of infamous choice when introducing no I, where I floats ethereally along with no, Conway's shorthand for the surreal numbers. No never really capturing I, but coming instead to a peaceable agreement with it for the sake of closing its algebra, meaning we get no I numbers back for any possible way we might add, subtract, multiply, and divide them. And more technically, no I roots exist for any non-constant polynomials made up of no I coefficients. No I has also come to be known as the Sur-complex numbers. They are like a field and algebraically closed, except they are a proper class rather than a field, making them a bit more powerful than any set, and it's not clear if the downsides to this distinction make any difference to physics. I actually only see upsides, and that's not due to some sort of generally sunny outlook. We don't pretend the surreals can ever be completely nor satisfactorily captured in any one set, rather they function on without end. No I takes the form a plus bi, where a and b are surreal numbers and I is the square root of -1, which we pondered at great length last time. In the shortest of summaries, I seems to be necessary and realized in the universe, even if we call it imaginary. Not a true composition, the no I truce is conveniently made via what is known as the Axiom of Choice, which Conway does not hide. He holds it up in his book every time he uses it, like dirty laundry, perhaps beckoning us to continue contemplating what precisely it and no I are all about. Perhaps you can already tell I'm not a huge fan of the Axiom of Choice. To catch some of you up, this axiom is simple on its surface as a mechanism allowing for choices from sets. Detractors might even call them miracles, sometimes used even for the sake of its great ability to generate paradoxical outcomes and absurd proofs. And honestly, the assumptions involved are a bit more miraculous than the typical axiom. Basically, it allows one to say abracadabra and pull a chosen, possibly random number from any collection of hats, including uncountably deep, infinite hats, or rather your bog standard sets, like marbles from occasionally infinite jars, and bring these miraculous selections together to not so much proof, but proof. A magical new collection, its own set, upon which you imagine a label of coherence as chosen numbers from their source sets. The real source of this sorcery is it supposedly holds even when we actually have no idea how we determined our choices, particularly in this pesky uncountably infinite jar scenario, such as a jar of real numbers, which are pretty much the go-to number system in physics. The problem is not so much what to choose, but how to choose, when it takes infinities of infinities just to begin to understand what you have to choose from. Randomness doesn't help much either here. If I imagine throwing a dart at a real domain, I'm still going to have one heck of a time accurately and precisely measuring where the dart landed when an infinity of infinite timescales must elapse before I can get resolution. Oh, just pick an approximation already? Okay, but I thought you needed infinitesimals for your calculus, right? Also, to get really real, pseudo-randomness abounds readily at scales such as ours, but true randomness is hard to make a convincing case for beyond what we can point to in our imagination. Hey, kind of like infinity. Amongst many other things, the axiom of choice formally justifies that vector or tensor we were talking about last time, such as imbuing its vector space with a guaranteed basis. And of course, magical thinking isn't all bad, as long as we maintain clarity on what is a useful dream that can bootstrap us to unthinkable new realities, something that can knock us out of our stale local minima from time to time, as imperfect creatures. Electricity must have sounded like magic at first, but then the critical next step is to interrogate these fantastical ideas with well-designed experiments and careful observations, and then be ready to reconsider. There actually seems to be quite a few suspicious choices involved in the axiom of choice. First, like we've already talked about, we make a choice to invoke a bit of magic to make these sleight of hand choices, without well-defined means, including adequate time to choose. Also, and this is always importantly specified, no jar can be empty when we choose, which is itself a bit of wishful magic, itself a choice. Like the idea we played with last time, you can see how implying multiple empty sets is a literal non-starter to any well-founded set theory. However, the slightest hand of them all might be the fiction of ensuring non-empty sets stay non-empty. If they are not empty now, the surreals make formal the intuition that they were empty in their humble beginnings. And as games, these sets could play down to their vacuous endgames again, in time, but for that you must believe in time. And the axiom of choice feels like a suspension of time more than anything. Abstractly holding apart numerical representations in independent dimensions like this is familiar, useful, and a natural feat of our minds. But to declare these abstractions to always hold in physical situations, no matter how we configure them, may infinitely shine like false idols once you contemplate such things at length. At the funny edges and corners of things we inevitably get on physical blow-up or paradox on our tally of math bets, I'm putting the axiom of choice squarely in the invented category of mathematics, a genius and useful trick of the choosy mind, but one not found in picking nature's most natural flow, where nature is what exists beyond some possibly natural mind. Although warning, this is not a position many mathematicians would take or even spend that much time worrying about. Luckily, I'm a physicist, technically anyway, and mathematicians are used to ignoring our occasionally problematic math skills and hyper-specialized intuitions. But to further defend this non-standard intuition on choice, the point of an analogy like pulling marbles out of jars usually invokes our poor ability to feign randomness. Not so much choice such as deciding there can be more than one empty set, or deciding to invoke a little magic to enable yet another alluring paradox of infinity on top of infinity. The answer often more infinity, seemingly at the heart of many a paradox. These aren't the imprecisely described choices you are looking for, and I don't mean that in the droid sense, I actually mean it. It turns out they make any number of paradoxes possible to imagine, before they break your brain anyway, all because you snuck a choice into your axioms that uncountably infinite amounts of time have passed. But you know, Oscar Wilde wisely wrote once that the way of paradoxes is the way of truth. As physicists, we're naturally attracted to the surreals because they do the things we've always need numbers to do. They remain quantized and ever aerated, even at their highest heights and tiniest epsilons. Even at some mind-melting birthday, they give us the tools to think clearly about what numbers we have just constructed, unlike sets of uncountables such as the set theory-based reals in our standard vector calculus. It doesn't mean we are throwing out infinitesimals when we still very much need them to calculate, but surrealized, we can use them with a much clearer awareness of what our assumptions are and what these flavors of omega and beyond can and cannot do. They can help us think and approximately predict, but they themselves cannot instantiate fully in the physical universe beyond these thoughts. It's a bad sign that everything falls apart when you back off from hard infinities in your theory. The universe can do some fantastic approaches to pi and e, but show me where it's perfect or necessary. And pondering where these guys come from, anyway, there are lots of good stories. But think twice before imagining the first cause assumes numerical infinities at t equals 0. As we talked about at length last time, in addition to the natives of the surreals, namely the reals and their perennially gappy extensions, we also need imaginary I for our physics. Since it's naturally missing, it was all too easy to introduce imaginary numbers via infinite time with an axiom of choice. But what if there was another way? Especially because we can construct all of the surreal numbers we need for physics without the axiom of choice, besides pesky I. I actually think we desperately need a theorem of choices, not an axiom that doesn't explain choice at all. We need a hard, clear, and precise mathematics of decision mechanics and dynamics, actual choices, not veneers on randomness, or pseudo-randomness anyway, which ignore evidence streaming in from every direction that time really does seem to exist. Now, Thus, steady yourselves, physicists. The dynamics of choice will not always be determined in the way we normally imagine when randomness or initial conditions and path integrals are our only choices. It'll be a dancy mix of more and less predictable moves. I should have been more precise because the odd and wonderful physicist of chaos knows very well that indeterminacy lives amidst regular and predictable order, and vice versa. And while what I'm saying is it may be practically undeterminable for us living at a certain scale, perspective, and thus projection of things, everything we currently leave up to chance may emerge from any number of frames experiencing choices they determine or freely flow with in their own time. Some systems at a large enough scale will result in predictable entropy maximization. Others, more strongly coupled across layers of abstraction, like living creatures, will find their own way, and within their regulated boundaries of flowing influence, entropy will not look so maximal. The mechanics and dynamics of true choice must be precise and robust, determined by one frame or several, but not just initial conditions, not just randomness, whatever that is. Even the empty set doesn't seem so random when its predictable games of numbers unfold as they do. Even if chaos is what emerges from time to time, not all clouds from the void will be unknowing, but rather there will be forks in the road where one path will be taken or the other. It's a glaring assumption about how games are intuitively played. In combinatorial game theory, typically we assume all options are instantaneously understood by each player, which is not usually assumed in the traditional or economic game theory of Nash and von Neumann. But even there, it's default assumed that the most rational choice for a given frame is played. It turns out, in the real universe, decision makers make mistakes. They have limited knowledge and awareness, and variable framing of so-called rationality. And some games are hard, provably hard. And actually, true free choice might just have everything to do with our evolved abilities to tap all forms of memory available to us, including that which we procure for greater and greater awareness, all via our friend, -1, and where it might come from. As far as understanding why John Conway and other geniuses like him thought and wrote as they did, I am continually humbled, often realizing too late what confused and befuddled me at one point almost always had wise reasoning behind it. Now, originally this episode went on for another half hour, introducing an alternative surreal approach to all the arguably problematic ones we've been admiring. But I must leave you in further suspense, as fittingly the content grew to loopily bifurcate this -1 into itself and episode I, now coming next in the series. The siblings, Star and One, will release as rapidly as possible thereafter. I only wish they could be born in fitting simultaneity with -1 to mimic combinatorial construction, of course. At least a dozen episodes are planned to follow. Speaking of which, I'd love to learn the secrets of all of you continuum wizards out there, as my experience appears rather limited by discrete steps in time. I fail to harness any continuum with its effectively infinite time and the limit of infinitesimal moments, for instance, to complete complex works in a flash. Alas, I only wish such continuum could exist, let alone be tapped, but it really does seem neither consistent nor decidable. I want to announce too that we'll start to simultaneously fold in more than one direction on this channel, also fittingly in playful yet discrete superposition. More plainly, coming soon are some simpler primers on the surreals and their generalized combinatorial games, without wrapping the complex ideas in quite so much relativistic art. My reticence rhymes with the poetry sung to us by our ancestors and our universe more generally, where much is partially lost in translation when collapsed into total order. But these simplifying measures are helpful to make progress on our journey to fuller clarity and comprehension. Hopefully you recognize too this move as evidence of my reading and responding to your comments in more ways than one, so please keep them coming. Perhaps you don't see these problems drawn out here for your contemplation, contemplation as much of issues as we make them out to be, especially because such fruitful physics has been born of our plucky vectors, matrices, tensors, and their vector spaces. And of course, your mind is mostly yours to make up. I recommend you triangulate with your own reading and experiments, your own calculations and conversations. But I argue the problems are much bigger and deeper than those indispensably useful tools listed. The paradox of completed boundlessness and its invention of isolations, along with their productivity, I argue sets us up to fail in our grandest aspirations before we even begin. But perhaps we'll learn to hold our rings a bit more lightly as we continue to dance and sing to that wondrous music which seems to come, impossibly, from none other than our empty set.